Okay, so I want you to go ahead and watch the video. You can watch the video first, then take notes, or do it at the same time. We're looking at solving radical equations, and with that you'll be able to identify radical equations and inequalities, solve them, and identify extraneous solutions of radical equations. So one thing with radical equations, you always have to check your work. The reason is when you check your work, you're looking for extraneous solutions, and that's a solution that appears to work, but then when you check it, it doesn't. And why that happens with solving radical equations is if you take the number -3 and set it equal to 3. Right now, we know that is not a true equation. -3 does not equal +3. But if I take -3 and square it, does that equal +3 squared? And you can see it does. Does that mean that -3 equals 3? Still no. So what happens with solving radical equations, when you square both sides, you can create a solution that looks like it's going to work, but in the end, it does not. So it's very important to always check your work. You have to. So with these, your goal is obviously to still solve for x. It's underneath a radical, so you need to get that alone, just like you normally would with a regular solving equation. So to undo multiplication by 2, we'll divide both sides by 2, and we have the square root of x plus 2 equals 4. And now at this point, since we have that radical by itself, we are going to square both sides. So in this process of getting rid of the radical by squaring both sides, we may create an answer that doesn't work. Okay, so we continue to solve. We subtract 2 and we get x equals 14. So you have to, this isn't a choice, you have to show that you're checking your answer. Now when you check your answer, you have to go back to the original because that's your original domain. It's got to satisfy that. So we have to ask ourselves, if we plug in 14, does that equal 8? So we get 2 square root of 16, and the square root of 16 is 4. And 2 times 4 does equal 8, so it works. All right. So if you need to pause and kind of go back through that, you can do that. Otherwise, you can go on to number 2, which is the cube root of 2x minus 5 minus 2 equals 3. So once again, our goal before we can get rid of the radical is we need to isolate this. Okay, so we need to get that cube root of 2x minus 5 by itself. So we're going to do that by adding 2 to both sides. And we now have the cube root of 2x minus 5 equals 5. Now in the last problem, we squared both sides, but our goal is to get rid of the cube root. So we're going to go ahead and cube both sides. So that leaves us with 2x minus 5 equals 5 cubed is 125. So you get that by doing 5 times 5 times 5. And now you have a simple algebra problem. We add 5. We get 2x equals 130. Divide by 2. And we're going to box it, but we still have to check it. So we're going to go back to our original to check. We'll plug in 65 for x. And we want to find out, does that equal 3? So we have the cube root of 2 times 65 is 130. And that gives us the cube root of 125, which is 5 minus 2 does equal 3, so it checks. All right, number 3, and again, if you need to go back and rewatch 1 or 2, you can do that. So number 3 is a little bit different because we have 2x, the square root of 2x plus 7 equals x minus 4. Now your goal is still to get that radical by itself, and it is. So we're actually ready to get rid of the square root by squaring both sides. Remember, if you square one side, you have to square the other. So this gives us 2x plus 7, but you have to be careful here. So you may need to do some work off to the side. Remember, x minus 4 squared is x minus 4 times x minus 4. And that actually equals x squared minus 8x plus 16. So you can see for this is a little bit different. We have a quadratic. We know how to solve for a quadratic. We need to set it equal to 0. So I'm going to subtract 2x and I'm going to subtract 7. And I get 0 equals x squared minus 10x. 16 minus 7 is going to leave us with a positive 9. And so we're going to factor this. We need two factors of positive 9 that add up to negative 10. So that one wasn't too bad. And we get x equals 1 and 9. And again, we have to check it because in that process of squaring both sides, we can create a solution that doesn't work. When you check, you have to go back to the original. So we're going to do 2 times 1 plus 7. Does that equal 1 minus 4? Then we're going to check the other one. I'll do it in a different color just so you can see. We're going to check 9. 2 times 9 plus 7. Does that equal 9 minus 4? All right, so we will simplify both of these. This gives me the square root of 9, which is 3. And does the square root of 9 equal negative 3? And that is a no. So we know that 1 doesn't work. So now let's check 9. We get 18 plus 7. And the square root of 25 does equal 5. So that one checks, and you only get one solution. So that's, again, why it's very important to check your answers. All right, now if you're feeling pretty good about this, you're welcome to go ahead and start your homework. But if you feel like you want another example, I'll go ahead and do one more here. So if we had the square root of 3x minus 3, so this is an example where we have two radicals, and your goal is still to isolate them. So if there was a constant like a plus 1, it would have to go on one of the sides. But there isn't a constant here, it's just a radical equals a radical. So we'll square both sides, which gets rid of our radical, turns it into a nice algebra 1 problem. I'm going to subtract x from both sides, and I'm going to add 3. And so I end up getting x equals 15 halves, or 7.5. And so we'll need to go ahead and check that. Again, we squared both sides so it can create a solution that looks like it works, but maybe it doesn't. So we'll go ahead and plug in 15 halves. And maybe you reach for your calculator to simplify. I would just keep your radicals here. So we end up getting 3 times 15, 45 halves, minus, if I get a common denominator there, that's going to be minus 6 halves. So that's the square root of 39 over 2. We want to see if we get the same thing over here. So this is 15 halves plus 24 halves. If I add those together, I do get 39 over 2, and those equal. So we know our answer is 15 halves, or 7.5. All right, so we will continue working with solving on Monday, but please make sure you practice your homework over the weekend as day 7, and then come back on Monday with any questions that you have for me. All right, have a great weekend, and I'll see you Monday.